Hello guys, let's get the stream started. Time to do some more good work. Let me just share the link. Last stream of the day. Let me just take a look at what the people have been writing here. Just some snacks after the workout. Hope you guys are doing okay. Okay. You need the script information as well. Just check out the download NLLB. Its output has the structure we'll be reusing across the board. I converted those Cyrillic files to Latin to make things simpler and faster, but having both scripts would be great. Okay. Does the first file mean initial models will focus only on 3 lengths plus English on the source side? Okay, let me just double check something, guys. Did I submit the latest code? Just a second. Did I go here and submit the latest code? Let me just see. Commits. Did I rename stuff? I probably did not. So in that case, everything is just called download parallel data. Let me just mention that to Rafael here. Okay, I think that's clear enough. Guys, let's continue. Here's some numbers. While I was working out, the script finished with running, and basically, is this done? I think it is. Okay, and basically we have apparently 12 million duplicates. Look at this. There is 12 million hard duplicates in Croatian. FYI, some initial exact pair duplicate analysis out of 99 mil sentences for Croatian, 12 mil are duplicates, are exact duplicates. I would expect very similar results for Serbian and Bosnian. That leaves us with 3x, roughly what, 90m, roughly. Okay, I won't write that. So that's the duplicate analysis. Let me just store the exact numbers. I'm going to just dump this here. So total before. Here's the number. Let me open up the analysis. Okay, let me just go here and mention that number of sentences after exact global dedup, we end up with what? We end up with total after, which is this, which means i.e. 12 mil exact pair duplicates. Let me see the exact number. Pair dedup. Roughly 12 million. Oh my god, what am I doing? Okay. So this is like 99m, and this is like 87m. Okay, and this is 12m. Okay. That's some analysis data, English data notes, English to Croatian. That's how I'm gonna call it. And then let's continue now with Bosnian. I'm going to stop this. So let's just kick it off. Why is this failing? Because this is none. Okay, fair enough. It doesn't even matter. Let's just kick off the run with Bosnian. Let's make sure we have the same types of results. So analyze data, we pick Bosnian here. And let me just quickly check that we didn't change anything here. No, we did not yet. We didn't do any splitting between Cyrillic and Latin for Bosnian. Because of that, we can basically just delete stuff here. Let me just see quickly. Bosnian, Latin, English, Latin, Cyrillic. Okay, that's the only one that has moved that to trash. Let me see whether we have anything else. I don't think we have. Close this. Again, Bosnian set here. Let's go to analyze data. And let's run dedup for Bosnian. Let's go. Kick off this run. And in parallel, let's see what happened with Serbian in the analyze script, which is not the best name in the world, but let's go. Okay. So this reported number is going to be increasing constantly because this dedup will be increased with every step. Okay. I think we'll have a ton of duplicates here with Bosnian. Let that thing run. And let's go and focus on, now it's running on TED. Why is that so big? Wow, 79 million. That's a lot. Okay, as for this script, seems it's finished with processing, so we can open up Serbian. Let me close down Bosnian, open up Serbian. Okay, this has data that we need, this has data that we need, this has data, this has data. All of this is done processing. So now we're gonna wrap stuff up. Looking good. Looking good. Looking good as well. Mozilla, TED Talks, NLLB, Open Subtitles, QED, all looks very, 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 very good. This one we already wrapped up, so we are good there. Let me just quickly open this up, copy the Excel end somewhere above, just for the time being. And let's see this script. I'm gonna call this script language script utils or something like that. I'm gonna call it like that. So instead of analyze script, we're gonna call it language script utils. And once we're done splitting, we have to call the place the files. This is just, all of these are just helper functions. I did add this additional, see how we can also remove non-printing characters. This doesn't really matter. Let me just quickly check what we've done here. We can collapse all of this. We could add this if we wanted, but does it really matter? That's a separate question. Let me quickly see. I could do it. Analyze, this is just experimental stuff. This is just experimental, so we can collapse it. Okay, let's call the place Cyrillic. This is what I would call right now, just to process everything. And once we're done there, we can go ahead and improve this to do. Or let's quickly understand what this one does. So there is the Unicode punctuation. There is the non-printing. There is the regex that's formed from this. And there is the punct or non that's formed from both the Unicode as well as non-printing. And then we form the final one with both the non-printing and the Unicode. Okay, so This replaces it. Let's see how this one is used in Stopes. Let's see how this one is used really. So it's formed there, and then it's used by just doing the sub with empty space. Okay, fair enough. So let's go here. Instead of replace, why not just immediately do this? And then you don't even need replace, because replace first gets it into the shape, and then this one removes it. As for the non-printing, these are just created like this. We map the list from 0 to 32 and from 127 to 160. We map that list to characters, which are going to be non-printable, and then we join them and we just try and find those. And that's it. That's it. So instead of replacing the Unicode with their non-Unicode, I mean the Unicode punctuation with the quote-unquote regular punctuation, instead of that, we just replace this to just immediately replace it with empty string, so it doesn't exist. And then we remove the white spaces, dashes, underscores, rest of punctuation, and digits. Again, let me just quickly compare this with what we have in Stopes. So what they do here, let's see. They do stripping and then lower. We don't have to do stripping because we remove all of the white space. Lower, we could have done lower if we wanted, but let's not go there. And then digit, okay, and then they also replace tabs with empty. So instead of this and this, I've just done all white spaces. And let me see what else. Normalize. Strip accents, replace Unicode, remove Unicode. What does remove does? Remove replaces the Unicode punctuation, so that one, and strip accents from piece of text. Okay, this one uses this Unicode normalize NFT logic. Remove non-printing just grabs this non-printing ones and replaces them. So this and this can be replaced with this. Fair enough. So there's various ways you can do this. What is this? Replace, replace, replace. Normalize spacing. Okay. Just a ton of stuff here that we will not necessarily find super useful now, but interesting to understand how it works. For different languages, you do different stuff. Okay, it's gonna be hard to parse. Whoops. Okay. So we don't have to replace. Let me just remove this. Again, Unicode punctuation is already used there. And then we use that one here. So we can just remove this. maybe add one more space, remove the to do, and we have everything we need. So we combine this and this into this one, and then that's the only one we use. Okay, looking good. Let's go and run this function one last time. And it's going to basically process our Serbian data so that it's properly split into Cyrillic and Latin. While in the background, we are running dedup for Bosnian. Good. Let's go, put a breakpoint, no args, kick it off. And let's just track initially how stuff progresses. There is one mistake we'll have. So if length is 0, continue, true. But also, if or length of files is 2, because in that case, already processed. So if either empty or already processed, we skip. By the way, I have terrible shoulder pain today, so I'm a bit struggling to hold the mouse, honestly. I think I overstretched something during the workout. We'll fix it. Okay, kick off the training again. Just FYI, if you hear me screaming, moaning, whatever is the term. Okay, let's go. First of all, okay, ELRC Wikipedia Health. Let's go. Okay, Wikipedia Health, here it is. So we go to parent, which is going to be the ELRC, and then corpus name, exactly. And then child directory paths are going to be, currently there is only a single path, and then we assert it's smaller or equal to 2, true, and then we add it to visited. And that's it. And then next up, we form two directions, both for the English Latin, and then for target we go both Cyrillic and Latin. And then what we do here is, I hate this verbosity, but yeah, it is what it is for now. We create the output files for the Latin are gonna be what? We join that language direction for Latin with elements, and elements should be corpus name always, and then English Latin, and corpus name here is gonna be target Latin. Cool, that's good. And then here we have Cyrillic path, and we join that with, again, English Latin and corpus target Cyrillic. That's all good. And then we find the files in the Latin directory, and we join them with the Latin path again and find files there. Okay. Now we sort those that don't start with files. This is probably less important in retrospect. We can just remove this. If it's bigger than 0, then we count the lines. Otherwise, we just remove. Same here. If we find the ones in Cyrillic, here are the 2 files. If it's bigger, which it is, we grab one of them to grab the original number of files, and then we just delete those 2 not temporary files, as you can see here. So we just delete those non-temporary files, which were the original files. And then, so we can basically, let me just comment this out. We don't need this. Non-temp, we don't need to sort. And same here. We just need to fetch the non-TMP ones. We can refactor this a bit later again, but it works. And then we sort, if it starts with TMP and has Cyrillic in its suffix, we grab those because those are basically what Cyrillic files in Latin directory. And then same thing here. If it starts with TMP and has Cyrillic, and we locate it in Cyrillic directory, Cyrillic files from Cyrillic directory. And same here, we have Latin files and Latin files from Latin directory and Cyrillic directory. That's it. So those are the 4 options we have. And then we just make sure all of them are either 0 or 2. That's it. Just a bunch of checks. And then let's go. We grab the output files, which is going to be English Latin and Serbian Latin in this first iteration. Both of those are going to be in the Latin directory. And then we go through the files. And we have here what? English, Serbian, Cyrillic. And then temporary English Latin. Okay, so that means what? Just a second. Does this make sense? Temporary. We grab the English Latin. Because we're dealing with what? Just a second. We are dealing with Latin, and because of that we find the Serbian Latin and English Latin. That's it. That's what we want to do. And we grab them and we open them and we just read them. And we go here again and we iterate. And now we have as the output we have in the Cyrillic directory. We open those. We go through the files, and the files should be Cyrillic. English Latin should be one. It says English Cyrillic because that's just an old bug, but Serbian Cyrillic, that's it. And then we write all of that until we finish. Okay, I think we can just kick it off. Let's just let this run. Unfortunately, there is no, I was not smart enough to write down the progress, which we should do, definitely, so that we know where we are at each point of time. So I'm going to do here the next thing. I'm going to do tqdm for file in files, open, and then tqdm with zip total equals length of source lines, for example, true. That's it. Are we done? Or where is it standing? Not sure where the code is. Okay, we're somewhere. Why do we have? I was not smart enough to log the progress. That's fun. Okay, we were doing CC matrix, so let's continue. That's why it's so slow. So far, so good. There are no issues. Do you plan to make some videos on module language? Maybe, if it turns out to be relevant for what I'm doing right now. I try not to pick up new tools just because they are new tools. Although I know that module will be valuable. Just looking at the initial performance. But it will take some more time to get there. Why wasn't I smart enough to just say, hey, print stuff? When you're processing, you need to print stuff. Like put a print statement here. Print. We're processing. Root directory. Okay. And then maybe put something like Exactly. And same here. Processing, 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 just preparing stuff. And then once we find the files, we just grab the files and we open them up, we read from them, and we write to the right output files. I think that's all the progress we need. Is this enough to make sure everything is correct? I think it is. All of these asserts I have, if anything fails, then that's bad. Let me just quickly see. So we count the number of output files. Both for in Latin directory and Cyrillic directory. Okay, I think we're done, right? Only analyze data is running at the moment. That means we are done and nothing failed. That's cool. That's probably then correct. I just need to double check a couple of things. This is kind of ugly. We'll be refining this code a bit. Like, this is very ugly. We do what? We grab the non-temporary files and we add the lines. If we have a non-temporary file, 0 and 0, that's going to count the number of lines, but we don't count the pairs, just the lines. We don't do 2 times 2. And then we compare that number, which is the original number of lines, with the new number of lines. And the new number of lines is you grab again English from both Cyrillic and Latin. Make sure those are the same. And then I do the same just for the target language and make sure those are the same. This should be correct. Let's now see the final output. In Serbian, this is how the stuff looks like. So Serbian has both Cyrillic and Latin. So English, Latin, Serbian, Cyrillic. Let's check a couple of these just to make sure everything looks fine. So let's open up English here. And of course it's not correct. We managed to mess up stuff apparently. Somehow, I don't know how. But unless we don't have any data in it's possible that none of the data was in Cyrillic. That's completely possible. In which case we probably don't want to create these files. Let's see, for CC aligned, all of these other ones should have data. There is no way this one doesn't have data. Exactly. And here also. No, please don't crash. If it crashes, it will crash our deduplication for Bosnians. No. We can just do this. Escape. Close everything. Okay, definitely looks good, except that I don't like that we have these empty files. I'm gonna delete all of this, and next time I'm going to just disallow that. So if we go to script. Where is the language script utils? We always open both files because we can assume that there will always be some Cyrillic or Latin, which is not obviously always the case. In which case, if number of lines is 0, we need to delete those files. Also remove those output files that have 0 lines. For fpath in out files Latin directory, number of lines 0, and then we count it up, and if it's 0, we remove that whole directory, and repeat the same process for the Cyrillic, and that's it, and that's it. Remove all unnecessary files. Okay, we'll luckily have the opportunity to quickly test this again. Unnecessary. Oops, unnecessary. So again, what we do here is these are the files in our Latin directory, and we count up their lines. If that number equals 0, then we just remove that whole directory. Same for here, files, number of lines. If that's 0, remove that one. Okay, nice. We seem to be done with Bosnian. Oh, Bosnian has less duplicates. So we maybe around 4.5 mil. So let's log those numbers. So total before, total before, total after, and total after, and finally pair dedup. Save all of those numbers. Just want to have those numbers in here. Data notes English to Bosnian. Data notes English to Bosnian. Number of sentences like that, and then like this after dedup. And then finally the number of duplicates was this. So put that number here as well, and just copy the same template as what we've done for Croatian. Let me just do the same thing. Okay, go up, go to Bosnian, copy that here, copy this to here, copy this to here, copy this to here, bold that, bold, bold. This is 6.6 mil, 4.6 mil. And then we have roughly 91 here. And here we have 95.5. Okay. Nice. Much better than Croatian. Much better than Croatian. And finally, Serbian, which has the most data. Again, this is gonna fail, of course, here, and we don't care actually. So let's put analyze data to Serbian. Serbian is now processed, so we can run it on Serbian, so it was perfect timing. Analyze data, run dedup for Serbian language, and let's see what we get. Just kick it off. Whoops, that's a bad kickoff. I have to specify analyze data config, and then we can run. Let's go. Okay, we can run it. God, this is becoming unbearable. Shoulder pain can get really bad. Okay, back to the script. Remove all necessary files. So here we first remove if Latin directory is empty, remove it. Here, if Cyrillic is empty, remove it. Remove the temporary files. And here we are making sure original number of files comes from the non-temp files, exactly. And make sure that the new number of lines before Cyrillic Latin separation. Okay, just to make this a bit more readable. Looking good. Let me just make sure we haven't messed up anything here while this is running. While the dedup for Serbian is running, and then we can kick it off for Bosnian as well. So we walk through, and if files is 0 or length 2, we continue. If it's already visited, we continue. Otherwise, we say reprocessing. Okay, first assert, we have 6 files in total. Parent directory. Can we make this somehow? I think if we used pathlib, I'd love to see this implementation in pathlib, honestly. That'd be super cool. If anybody on the stream wants to do it, let me know. I can paste you the code. Parent, corpus, children. Assert this is smaller than 2. Add all of them to visited. And let's continue. So we create both the Latin and the Cyrillic directories. We create the output files, which are going to be Latin and Cyrillic. And then files in the Latin directory, and files in the Cyrillic directory, and then we split them. Non-temporary files, we don't need to sort them. but let's sort them, whatever. And if the length is bigger than 0, we count the lines. Okay. And then we remove them. And same here. For the only thing that I don't like here is this having to files Latin, having to go and grab the base name. It's kind of bothersome. Can we do this somehow better? I don't think we have to. Okay. If it starts with temporary, grab them in the Cyrillic directory and grab the number of lines, and then we remove all of those. Get the non-PMP original files, count the number of lines in them for later verification, and remove them. Prepare the output files, output directories, and files. Collect current files in Latin Cyrillic directories. Collect current temporary files. Non-temporary files. Collect, these are all current files, and then out of those we grab, so collect all. Okay, should be good. We could probably do a couple more things just to make this a bit more nicer. Like, let me think. Like these base names. What's the ugliest part? The ugliest piece is this here, I guess. We have to grab the base name twice. Why? Well, it's either that or here we have to go to do OSPath join, so it doesn't really matter. Okay, let's just make sure we validate everything is 100% correct. This cannot fail. This should not fail. Let's do original number of lines in the source, in the target, and then here, compute that as well. Exactly. Here as well. Exactly. And then let's compare that as well. So here, assert that this equals original equals this equals this, And here, these two are equal this two and equals this. That's it. So now we know that the original number of lines after splitting into Cyrillic and Latin is the same as the final number of lines. And the only left thing is to, remove the empty ones, and we did do that. So, okay. Guys, we are good here. We can kick this off for Bosnian. But before that, I want to quickly, before I ruin Bosnian, I just want to make sure that stuff is working for Serbian. Opening up this one, opening up this one, put it on the right, put it on the left, pick a random position in the file, and make sure they're the same. 35256. And the Lord spoke unto Moses. That's correct. That's enough. Here, I'm gonna close this down. Let's open up after the Bible. Let's open up this. Serbian Cyrillic. Let's pick a random line from theory to experience. 952328. Looking good. And maybe the last sentence. Looking good. English Latin. Serbian Cyrillic. Put it there. Sorry, Serbian Latin. And here English Latin, okay? CC aligned is just so bad. We might be, we should probably remove the whole damn file, honestly. The whole damn corpus. It's so bad. It almost looks like they scraped Pornhub and some nothing else. One, 2, 8, 9, 2. Most of this is Cyrillic. I'm thinking it's dangerous to remove stuff if it's a mix of Cyrillic and Latin, because sometimes it's legit, but oftentimes it's not. I'm literally trying to find a cohesive sentence in this whole corpus. I kid you not. If there is one corpus we should remove, that should be this one. Guys, I can't find a single correct sentence here. A single correct sentence. Always combination of Cyrillic, and I can't find a single Latin sentence that's correct. Single Latin sentence. Such a pile of trash. Whoever made CC aligned, like, I think it's Facebook. Like, this is like a shame. I'm looking for a single good line. Single good line. I can't find it. Did it literally just scrape troll and like Pornhub and 4chan? This is just porn. We should 100% do filtering of toxicity. 100%. This needs to be, we need toxicity filtering, especially we need toxicity filtering, especially for CC aligned, if we decide to use it at all. Okay. How is this? And LID filtering, we need to do all of that. I still didn't find a single sentence that's in Latin. This is mostly Cyrillic with, if it's Latin, it's gonna be like English or something. Where did they find this data? Like, it's fantastic. ACC matrix and Serbian. This is with Serbian Cyrillic. Let's go to this line, like 6109378. Looks it's good. Same number of lines. Latin will probably also be super low quality. Let's go to random line. CC matrix, Serbian Latin, English Latin. Let's go to 9280754. Huh, I didn't open up the right one. One 0965939. Latin. Nine two eight 0734. Okay, looking good there. So it seems it's mostly good. So I don't think we have to check everything. English, this one is empty. Delete this one. Okay, let's see here. Nice. Let's continue here. Nice. Okay, let's go here. Nice. Global voices. Okay, this looking good. Nice. Wow, okay. Gourmet. It has data. It has data here as well. Okay. Macaco, I know this one has data. We didn't even touch it. NLLB, I'm sure it has data. It has too much data not to have Cyrillic. Okay, same here. Set times. This one doesn't have data. Delete it. Almost done. Wiki matrix. Looking good. And here as well. Awesome. We are good. Maybe quickly seeing the Cyrillic would be good to skim this and just make sure that This data is indeed mostly Cyrillic and Latin respectively. We have like 25 data sets, so it's feasible. We can quickly skim through stuff and make sure. It looks good. CC matrix. Cyrillic looking good. And this one as well. Cyrillic looking good. Latin also. Latin looking good. Cyrillic, Latin, Cyrillic, Latin, much smaller in Latin. EU Bookshop, Cyrillic, Latin, Cyrillic, Latin. Okay, this one has more data in Latin and has some Arabic apparently. GNOME. Serbian, Cyrillic, Latin, Cyrillic, Latin, we don't have to check this one even. This is the highest quality data set, pretty much. Makoku. Mozilla, Cyrillic, Latin, TED Talks, Cyrillic, Latin, OpenNLB, Cyrillic and Latin. We don't have to check all of them. Cyrillic, Latin, roughly looking good. And Cyrillic and Latin and Cyrillic and Latin. Cyrillic, Latin. There's a lot of Cyrillic here, but it's counting the number of characters, you'll find more Latin. That's why it's here. Cyrillic, Latin, Cyrillic, Latin. Okay, Serbian looking good. Bosnian is of better quality, only 4.5 mil duplicates. And here is the Serbian. Serbian has 10 million. Nice. So somewhere like a bit better than Croatian. So total before, total after, and finally pair dedup. Let's grab those numbers and store them here. Serbian, let me just paste the template from Croatian, data nodes from Croatian. Grab these nodes here, go here, data nodes, English to Serbian. Whoops, what did I do here? I only need this. Okay, I only need this, and let me just paste the actual numbers, copy this, go here, copy this, go here, copy this, go here, bold, let me just bold it quickly. So roughly the results are 10 million for Serbian duplicates. We are left with 94. We started with 104. That's the result for dedup. Awesome. That's it. That's all fine. Let me just think for a second. So we know the number of sentences. We did go through the line lengths as well. We did notice that weird pattern in line lengths. I'm still waiting for someone to take it on and solve that one. If not, I'm gonna take it myself. Let me just make a note in the server. And next step is to run this on Croatian. On Bosnian. We run the script utils on Bosnian. So for that we need to do what? Set this to Bosnian. Whoops. Go back. BOS. Looking good. That's the target language, and we start with BS here. So again, Bosnian. Let's go. Let's do it. Should work out of the box, same as for Serbian. And should be even better because we should now have actual progress being printed. Whoops. Well, of course. We can stop that and pick the right analyze data. No arguments and run. Okay. Well, that was something that I should have expected. We have to first call split, and then we call this one. Okay. So we first split the corpora, and then we place Cyrillic and Latin files. So split and then place. And then we have helper ones, and then we have experimental thingy, and that's it. This should now work properly. Let's run. Let's go. Okay. Files, grab it's gonna be the English one. Why do we assume this is English? Aha, if the source is inside. Okay, sure. Makes sense. Create the source and the target path, grab the corpus name, and we're processing. And then let's go and we open the read, we read from them, and then we prepare the line, and then we split them according to whether they belong to Cyrillic or not. Fair enough. And then we just create a ton of different Latin. So again, we're gonna have let me see, English, Latin. So source should always be Latin, and target should be switching back and forth. That looks correct. Go here, run, and then we go through different paths. So through different lists here. We have the target data path, we have the source data path, and we have the Latin lines and indices. So we go through Latin data and we place it into the this is also, wait just a second. So we have Latin data and we have source data path Latin pair. This is just, I have weird variable names here. Target data path Latin, source data path Latin paired, and Latin sentences. And so we open up those target and source ones and we grab the source and target because that's how we collected them, and we just write them. So grab the Latin sentences and write them down into the temporary file, and then run, and then we are now Cyrillic. So we have Cyrillic outputs and Cyrillic both for the English and for the so for Serbian it's going to be, so for Bosnian Cyrillic, for English it should be just English. But will this not now interfere? Yes, it will. Yes, it will. Okay, so this is why I had, let me just think for a second, because all of them we dump 2 times same files. So this one and this one have, this is literally the same string, so they will override each other. So that would be a bug. So because of that, we have to somehow distinguish between them. We have to somehow distinguish between them, and we do that, well, basically by adding Cyrillic to this one, calling it English Cyrillic. Because it's a temporary file, I think it's fine now. So like, just name it Cyrillic, or sorry, this should be Latin, this one should be Cyrillic, because it's paired with Cyrillic. Okay. Okay, stop this because we made a mistake. Delete, delete. Kick off again. Bosnian Cyrillic. English Cyrillic. Okay, I'll just continue doing this. Should work nicely. Okay, this is now running. I'm having a terrible shoulder ache. Let me just double check. We don't have any issues because of and then here okay, this should work. This should just work. NLLB is gonna go a bit slower, but we're almost done there, guys. We're almost done. Going back here. What are the Opus nodes? Okay. We're done with this. And we're done with this. Next up, train the HBC tokenizer potentially, understand the spikes, LID toxicity. I think we can play a bit with LID, just to understand. We had it open today. Ah, so he translated it, or? Nice. Super cool, people are helping out here. That's nice. Okay. Let me ping Chris about. Let me just go grab some water, guys. Okay, this is progressing. Let's wait until we get to here. Who's this guy, by the way? Or girl? Ah. Okay, well, wouldn't hurt to try both of these. Let's set up these two, and then we're gonna figure out what's the difference. But let's set them up and try and run them on some of the text we have in Bosnian, and see whether it detects some Turkish, some German, some English, other than the Bosnian language. So yeah, let's try and do that. I'm not sure what's the exact difference between this project and the one that NLLB team has released, as I asked Chris here. Let's see what people say here. This is the latest model as noted here in the NLLB project. Okay, fair enough. Of course, it's non-commercial. Inaccurate language detection for short phrases like greetings. Let's see what people say there. add the language tag. Let's see what this does. It's not open source, at least not this model. Okay, so here is how we can use it. Just grab the model, grab the fast text language identification model bin, load it, and predict. Training procedure, if we ever have to train such a model, we use the Stanford word segmenter for Chinese, MACAP, and UET segmenter for Vietnamese. From the Europarl. Okay. So it's again non-commercial. And this is the old one. Okay. The new one is explained, its training procedure is explained in the paper. Thanks, Daniel. I'm currently actually at my lowest productivity because I'm hurt. I managed to fuck up my shoulder, so I'm kind of in a pain trying to work, but I'm gonna push through this session. And yeah, let me go back here, see how we're progressing here. And then I'm just gonna add the LID filtering somewhere here just to play a bit with it. So maybe inside analyze data, I'm going to add additional function, which is going to do what? Let me see. LID. We can add the LID feature. And then, okay, let's do something like this. Just add LID, set that to 4. LID filtering or LID detection language, or just LID. like this. I'm gonna import all of this in here, load the model. Let me see whether we have this already installed. This will be good. So we have the model, and now we just have to, after we load it, just do the prediction of the actual text. And let's see how that's gonna work. So next up, when we get here, this one counts the lines, compute the line length file, blah, blah, blah. Here we open it up directly and then we read the lines. We can do the same thing for LID. We go through the lines, we check what's going on, which language it is, and then we save that. I think we don't probably have to go and do it like this. Just a second, let's see. Count the lines. Okay, we can just pass in a single file. Same as here. Compute line lengths. Let's start from this logic and then we're gonna just refine it. So given the file path and given the flag information on is this a gzip file or not, is gzip we go through the lines. We don't care about the length itself, so we don't do that. Instead, we are going to remove that. Okay, let's just remove all of that and put this line here. So we're going to predict a particular line, get the prediction, and we can store that. And if it's different than English, we can kind of flag that. Length. Let's make it lang line. How can we call this? LID per line or something. Dictionary, I don't know. And here we just put if prediction different than, let's say, label English. In that case, we store it here, and thus we modify it. And then we can just call this thing here. If feature LID in features, if languages is none. I think we do, yeah, exactly. Except that we don't specify this here, because otherwise, actually we do specify it there. Or do we want to do for every single data set in the corpus? Let me see. Do we want to do this for all data or just for some? This is kind of the global dedup. Do we want to do... Yeah, let's do global. Let's do a global one. I'm going to do the same thing as here. We're going to refactor all of this later. For now, we're just extracting insights and thinking about refactoring a bit later. Okay, here we are. So here we are going to add, I'm going to fill it inside here. And then at the end, no, we don't save here. We just check what's going on in here. Maybe you can ask, like, if this is in features, then we can dump it maybe, and you can also just print the number of non-English lines, whatever. Let's just test this. I quickly want to test this. So specify just LID and specify, let's go with Serbian. So analyze data, let's go with Serbian, and let's go back to analyze data. I think we're good now here. We analyze the data, and the only thing we're gonna do is enter inside of the LID branch. Everything else remains untouched. So this looks like this. This is the only code we execute. So let's kick it off with the right config file. So we go and specify the analyze data config, kick it off, and let's see where we get. Okay. If it's none, as it is, wait. Aha, I messed up. I just have to expand this, collapse this. Enter. We load the model. The first time we load it, we'll have to obviously pick it up. It's 1.18 gigabytes. I wonder, is that just because it loads? I'm not sure what it looks like in the background, but it could be just a huge embedding table with something on top of it. We'll see. And then we'll load the model. We open the file, we go through the lines, we predict. Is this gonna fail? Apparently yes, because it processes one at a time. Remove the line. Here. Let's go back, analyze data. So we go through the file. We grab the line, and line is gonna be line strip. We strip the line, and then we count stuff. Okay, let's kick it off again. We definitely don't want to load this every single time here. So what we're gonna do instead is grab this here. And in the beginning, as part of the setup section, here we do if this, then this. Model path and load the model, and then path in the model here as the first argument, and then passing the model down there in the call as well. And I think this should now work. Let's just not stop this processing, that would be super bad. Kick it off again until we get here. I just want to get here. Let's go. Line Russia predict English with some confidence. Huh. So what's the actual output? Can we step into this model? The first thing is just why is this such a weird format? The first is a tuple with a single element, and the second one is a score. Looks like a NumPy array. What's the actual format here? So if we extract 0, 0, then we get the language or what? So like if I grab prediction of 0, I get this, which is a tuple, I assume. Looks like a tuple. And then if we grab 0, 0, we get the string, I guess. And that looks like this. Label English Latin. If this is different than this, then we add it. Else if prediction is equal to label and exactly this is smaller than equal to 0.5. In that case, I'm curious, why do we have this? Why do we have this one? Why do we have such a low confidence? We could also specify k, where k can be the number of predictions we want to output. In that case, we have array here, array there. Got it. In that case, specified for the predict method. Well, let's specify k3. I would just be curious to see a bit more here. Okay, that's it. We can stop this now, analyze the data, stop it. So we predict if the label is different than this, then in that case, I want to see the, no. Here I want to see for the line, let me think for a second. What do we want to store? We want to store the line and the prediction. What was the prediction from the model? So it can't be really a dictionary. We can just add a list, doesn't matter. We can just do something like append here and then a line together with its prediction. Especially the, yeah, we can store the whole prediction. This is what I would do. And then rename this to LID per line list or something like that. Okay. So then this one will be just a simple list, and we need to rename it into a list, just to not to be misleading. Okay. Let's go. Or if we were to store corpus, if we were to store the corpus, And for each of the corpora, yeah, maybe we can go like this. Sorry, let's go like this. Let's make this a default dictionary of a list. We pass it in together with the corpus name. Together with the corpus name. Go here. Corpus name. Append. Will this work? It should work. To that list append yet another line and prediction, and then by doing that we get for all of the corpora we get the list of these weird lines, and then we can do all sort of analysis. Kick it off. Will it work? Predict. Top 3 predictions, English, Italian, and this other weird language. And just run until we get to a weird line. That was quick. Deutsch. The first line here is already German. It says US. That's messed up. What's the confidence? The confidence is very low. Okay, so if it's different than English with a certain confidence and the prediction is bigger than 0.5, in that case, or let's say even equal, if you're confident that you're not English, then I need to investigate. Also, if you're English but you're not confident, I'm just curious to see that. Let's maybe grab those cases. Stop and rerun. No, this is bad. This is bad. Wait. How is this bigger than 0.5? Oh, it is. Okay. Let's continue. Interesting, all these shortcuts are classified as weird stuff. With very high confidence. Even London, Japan. Okay, let's do it like this. Only if the line and the line needs to be a bit longer. A line needs to be like, I don't know, like length, and the length of the line when split needs to be bigger than 1. So at least 2 words. Or we can just ask if line length is bigger than like 10 characters, I don't know. Again, stop the analysis of the data. Kick this off. What's up with prediction? Wait. Prediction of 1. Okay. How did we enter here? I don't understand. Prediction of 0, 0 is not even English. This is German. Or, yeah, Deutsch. If this is true, which is false, so then how do you enter here? Ah, it failed. Fair. If this is not supported between instances of list and integer. What's a list? Aha. My bad. This length needs to be bigger than 1. Rerun. What's the line? New York. US. Bosnia. What? English, but not that confident. World War II. New York. Microsoft. Microsoft. Bosnia. Run. Let's just see what is going on. Okay, definitely has to be a bit longer. Let's make sure that the line is like longer than 25 characters. What's that? Like this, and then at least a bit text, a bit of text at least. This we don't have even 6, 7, 8, 9, 10, 11. Let's go above 20, just to kind of, or 25. Let's just introduce the, make it a bit easier for the model. It's currently very stupid. Again, here also, we need to have some confidence in the length. Run. Interesting. Okay, stop it. Only if you're very confident. So only if you're very confident, if it's not English with a big confidence. And you're English but very unconfident it's English. We don't even need this. Let's just do this one and see what we get at the very end. That's what I'm gonna do. Okay, we definitely need to add, as usually, TQDM. Without TQDM, we have no idea what's going on. So let's just add TQDM, wrap this up here, and now rerun. UDM, but we apparently have to set the total or something. We have it. This one, okay, looking good. File lines, TQDM, enumerate. Will this work? I really want to see the progress, even if that makes us slower. Yes, please, progress. Okay, that's a lot of inferences. Let me see. I doubt we're running it on a GPU. It's probably just running on a CPU. 100% running on CPU. So this was for 1 million. It's gonna take a while, guys, to analyze. We have what we said almost 100 million for Serbian actually. So it will take 100x what we saw here. Plus, we're going to completely ruin this because if it's different than English, this is again a mistake on my side, because we need to, not English, but like whatever the language of the current file is, that's what we need to check. Okay. Yeah, I understand what went wrong there. Let me stop this. Again, we're gonna pass in LID, and we pass in the language code 1. Okay, we're gonna pass in the corpus name and the language code, or the model, the language code, and then here the model, the language code 2, the file 2, and then enter here, and then model and the language code, okay, which is BCP47. So that means we just need to make this an F string and make this a language code. So if you're different than this, so if you're currently dealing with a file that's English and you're different than English, then add that. If you're different than Bosnian, we're dealing with the Bosnian like Latin or whatnot, then we also need to save that as well. Okay, should be better now. Let's go. Kick it off. Okay, what's this? English Latin. Enter. Okay, this is actually German. Let's go, let's grab these. We can now actually try and analyze. So If it's different than the label we're expecting, with a certain confidence on a certain line length, then mark that. Serbian Cyrillic. That's going to be probably oftentimes the case. We passed in Serbian Latin. Why did we pass in Serbian Latin? Just a second. Why did we pass that code? Because we are dealing with Serbian Cyrillic. Okay, that means the code should be, no, okay, this is the error. We have to modify this function so that they know how to handle the script here. So if it's ambiguous, you grab the language code. You can grab the language code from the file name. You can grab the language code from the file name directly. Just do this. Just do this. And then remove the language code from here. And we just make this and here as well. So just equal to this. And language code is just, we don't need this. We don't need this. Language code is simply file1 split on the dot. And then we grab the last element here. File2 split on the dot, and then we grab the last one. This should work. So the language code is computed by ignoring the whatever comes from here and instead focusing on this. I think this should now work. So I'm going to stop the analysis, re-trigger this. Run. Okay, English Latin. Exactly, Serbian Cyrillic. Because this file is, as you can see here. Okay. Let's go. The first code is English Latin, so let's fill it in. And then we can analyze immediately after the English is over. We can go and analyze that data for the excellent file directory, sorry, corpus. Okay, let's see, guys. What's the length here? What's the length of this one? 5,911. Okay, well, okay, let's just let it compute. Keep on computing. Keep on computing. Keep on computing. How can we distinguish? Yeah, we should distinguish between these two. So for this corpus name, but for this language code, these are the outliers. Otherwise, we won't be able to distinguish. Okay, last time, that's it. Now we can just run until completion. Once that's done, we can just go and save it as a JSON. And then we can analyze the whole Serbian corpus. We can analyze the whole Serbian corpus and anything that might look suspicious. Yeah. We need to play with thresholds as well. We'll need to play with thresholds both for the line length and for the confidence. But let's just kick it off. I won't touch it now until we get to the very end. And we just have progress, so that's all fine. What else? How is this one progressing? The other one almost done. So NLLB being split into Latin and Cyrillic. We're almost done there. Bosnian. And while we are waiting that to complete, we can play a bit with the other LID system. Oops, we can just that. Let's see what this one does again. So high performance supports 201, fast text. Okay, it has more permissive license. I guess that's why Chris sent it. Did you send it mainly because it's permissive? It has permissive license. So Chris sent it up there somewhere. Or is this just a dataset or also the LID? Let me see. Is this just a dataset or it also has identification? They do have the model. Let me see whether this guy also has any other repos that are relevant. I keep saying guy, this is Lori, girl. Sorry, Lori. It's the best comment ever. Daniel, if you're still here, this made my day. Okay, and so once we download it, we can run it like this to get most likely labels for the data. Download the dataset and convert it into the format. Citations and line. Okay, is there anything else we need to know here? Languages, logo, blah blah blah. What do you support from languages? Okay, Flores 200. Fair enough. Quantized model. Oops, what did this say? Are likely to be polluted. Whisper, Crawl, Wikimetrics, and Opus. Some of these are likely to be polluted. Sometimes contains sentences in other languages. CLD2. We should check out CLD2 as well. Contrast 3 LID systems. CLD2. What's the name of this one? Open LID and NLLB LID system. Also, is there any rule of thumb for how many sentences we need per length if we want to train tokenizer? Any pointers would be super appreciated. What's the data cleaning about? Sample tools, detokenizer, normalize punctuation, remove non-printing characters. Okay, these are just used all around the place. People really love to use Perl because I think they're just copy pasting from each other. Can I get like a description of part of Moses? Of course. Everything's part of Moses. Well, let's just try this model. Where's the paper she mentioned? Does she have any performance? Nice. Nice, she outperforms. She outperforms all of the other ones. Huh. Okay, I got a reply for that I had for question for Chris. So apparently, on the intersection between 200 Flores 200 and CLD3, which is 95 languages, it outperforms both systems. Nice. And then what's here? For each language class in the taxonomy, we give the count of the languages covered by the classifier in that class. Nice. We should read this. Let's read this. I'm gonna put this as a reading list. Open LAD. Apparently better than NLLB plus permissive license. That's great. Nice. Super cool, guys. This is super cool work. Let's go to Fairsec and let's just let's navigate to the data script, copy the path, go here, navigate there, grab this, get this one. Let me go grab some water, guys, while this is running. Oh no. No. Oh. Ah. I see now. I see what crashed, but luckily the good news is we oh no, wait. We need to use this Mm. Mm-hmm. See what this one is. Can we do sh-util remove directory? I think no, remove tree. Remove tree is the one. Exactly. This is gonna work. And we have to do the same thing up here. Remove tree. So we messed up. We messed up here. For which data set? I guess it's just the first one, the excellent. Right? If we go here and we print it, it's gonna be excellent. No, it's actually ELRC Wikipedia Health. Let's see. ELRC Health. Why did we try to remove anything, really? This doesn't look... Wait. Something is wrong here. Why do we still have... Aha. Where is the other one? Grab the partial ones and save them, and then... Okay, just stop it. And let's go to... Hey, Bollywood, because, yeah, this is not just a toy project. This is a much more serious project where we're trying to do, like, I literally have 300 millions of sentences for these 3 languages only, and there is a ton of processing to be done and a ton of analysis and understanding everything from data downloading to filtering to processing to training to FSDP. There is a ton of things. So that's why it's taking a bit longer. And it will take, this is a project that we'll be doing over the 3 to 6 months period to just get to some of the milestones. So we're just getting started. Okay. Why did this fail? Go to Bosnian. Make sure all of them have, okay. Make sure that all Bosnian has let me see. Remove the temporary files. Did they reply to a question? It's a similar question to why does Twitter need that many engineers to run Twitter, or Google to run Google search? It's hard. How are you doing? Okay, this looks good. Okay, so now, well, now we don't want to do this again. We just want to resume with no arguments, resume this code here. Okay, why are you stuck with NLLB? Aha, you're stuck because you were loading. Bosnian has a ton of data inside of NLLB. That's why it's so slow to load the lines. Guys, we are almost done here. This was amazing. Updates. All Bosnian and Serbian have been split into Cyrillic and Latin scripts. I'm also playing with the LID systems. We're getting close to the filtering phase. Okay. Let me see my to-dos. Did I download this at the end? Yes, we did. We downloaded the model. Now that we've done it, we now need to do this command. We just list quickly. So we have the LID model, and we have to unzip it. It can be installed. Apt install pygz. Unload this one. Done. And now we can just run apparently fast text predict. I think we have, let me just see, pip list, just grab fast text. Yes, we have it. Nice. So now just run it on a piece of text. I'm not sure. Let's see how fast text works. Fast text GitHub. Let me see how it can be used. What's the expected format? Requirements, building, fast text. Input data.txt is a training file containing UTF-8 encoded text. By default, the word vector, okay. I'm more interested in classification. Okay, piece of text to classify per line. Nice. Let's run this. Let's try this. Go to data. Test.txt. Ćao, ovo je rečenica na srpskom jeziku. Srpskom jeziku. Hallo, zusammen. Wie geht's euch? Okay, I think Bosnian is done. Nice, 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 guys. Nice, Bosnian is done. We're almost done. It's kind of stuck. We'll check the quality a bit later, but it looks like we are ready. Nice. It also seems most of these don't have. Interesting, not even NLLB has Cyrillic. Really? That's fun. That's surprising. We'll have to double check everything makes sense. As for the analyzed data, what are we doing? Oh, we're still running a ton of predictions. Okay, we are running. Oh my god, look at this. Madness. We're almost done though. Just let it run. It's gonna be a huge dictionary. We might have messed up. Let me see what's the size after we get here. Analyze data. I'm just gonna put a breakpoint somewhere here, otherwise this will fail being too big. Or maybe we can immediately stop it. Let's just see. How big is this? Let's grab a random data set like this one. So if we get this, and if we do like CC matrix underscore English Latin, this gives us how much data length? Okay, 425. That's actually good. We can actually just keep on going. Just keep on going while we are dealing with this. Grab this data. Let's just replace, let's just replace data with test.txt and print that out to out.txt, something like this. So predict using this model. This command has not been found but can be installed. How can one use command line utils from fast text? Let's see. I think I opened it up somewhere. Okay, here it is. Command line and how do we use this? let's find the fast text. Change directory to mini conda NLLB, maybe lib list. Maybe do we have anything that's like fast here? Sorry, list, and then grab fast. No. Let's see what else we've got here. Binary. Is it where is it stored? Wait, if we open this here, if we create a temporary file, there's a ton of changes I made. I have to push this out before something happens to my computer, God forbid. Import fast text, and then fast text. Is there a predict method? Can we do something like this? Let's try run with no arguments. Yes. Run. Did it fail? Of course it doesn't have any module predict. But if we go here and if we see where we are, okay, we are here in the site packages, and then there is this. So let's see how the main function looks like. We could just call it directly. cbow train read, load the model, build arguments, parse stuff, quantize, test the label, test, save the model, get the line, get the words, predict. So given a string, get a list of labels. Okay, let's see how this is used. Is there any example how to use this? Load model. Let's see where this one is called. Let's go to TMP. What happened here again? Ah, that's fine. Okay, just go. So what do we want to do? We want to call on load model. And then we want to call the binary we just downloaded, which is this one. And I think that gives us back the model. And then we can do model predict, I think. So print model predict, this is a text. Will this work? This should work. So we grab the model, we load it, and then we call predict. I think this will work. This is how it looks like from Python. It's a bit different from the command line, but for some reason, I'm not sure how to set up the command line. This might be the fastest way. Again, this failed. Cannot be opened for loading. Why? I'm not completely sure, honestly. Okay, guys, I think we're done for tonight. It's almost midnight in Belgrade. We've done a ton of work today, and currently we're running the cell ID from NLLB project. We're gonna see the results, and I'm gonna set up the open LID tomorrow morning. So that's gonna be the plan. By the way, in a couple of days I'll be going to China for a trip. Again, if you didn't hear this, so that means from 17th to like 26th, I will not be streaming. I'm gonna make that announcement. But yeah, just FYI. Okay, guys, have a good evening, have a good day, have a good morning wherever you are, and catch you tomorrow morning, roughly. Let's say, let me see what plans I have for tomorrow. I don't have anything tomorrow morning, so I might start even earlier. So like, let's say maybe around 10:30. Cheers, guys. Have a good night, have a good day, have a good morning. Bye-bye.